Good day to all. Today we are going to see about that speed control. First introduction and requirement of speed control, then type of method of control of induction motor, then advantages and disadvantages, then the conclusion. See, what is that meaning of speed control? Various method of controlling of speed induction motor can be visualized here, but the formula for that equation is ns equal to 1 minus s into ns. The rotating magnetic field with the constant of magnetic is produced the rotating with the speed with ns equal to 120 f by p. This speed equation we will use most of the time. So this is the main formula to find out the speed. Ns equal to 120 f by p, where f is equal to frequency and p equal to number of poles. The requirement of speed control. Why need the speed control? See, speed control means change the drive speed as desired by the process to maintain a different process parameter at a different load. It is energy saving also. Speed control is different concept from speed regulation. Now, where there is a natural changes in the speed due to change on load on the shaft, and the speed control either done is manually by the operation or by the means of some automatic control device. Then low speed starting requirement. Then the method of speed control of induction motor. There are 5 main methods in that speed control method. First one is stator voltage control and stator frequency control and stator current control and V by F control, which means voltage by frequency control and static rotor resistance control. These are the speed control of induction motor. First one is stator voltage control. As I said before, this is the main formula for that find out the speed. Ns equal to 120 f by p, and f is a frequency and p is a pole over here. So it is used to find out the speed. The synchronous speed is ns equal to 120 f by p, and the torque equation over here, it's t is proportional to the wt. Wt is nothing but a w squared is nothing but a speed. So see here, the torque tau is in y axis and the speed is in that x axis. If you see here, it is this line is a fan load line, and this is voltage V1 and V2, V3 with respect with that speed. Here it's torque and speed. See, if it is the voltage versus speed means the torque is slightly increased with the speed also. For particular time it will decrease. Torque will decrease, but the speed is slightly increased. As well as V2 have same like for V1, but is lesser than the V1, and also some particular point it will decrease. Likewise V3 also, it will increase, it will decrease some more time. So in this fan load we'll have this is N1 and this is N2, this is N3. The main concept over here is V1 voltage V1 is greater than the V2 and this V2 is greater than the V3. This is the stator voltage control. If here frequency is high, the speed will also high. The speed will varies with that effect of this frequency. If the frequency is high, the speed will also high. So if you want to decrease the frequency, then we will reduce the speed. The rotor resistance R2 constant slip small to S2 small that can be neglected. Therefore, T proportional to S e to the power, where E2 is a rotor index EMF, hence T is proportional to V squared. This method easily and simple. See, then we'll go for another voltage control method, variable terminal voltage control method. Here also we'll have a curve for torque versus speed. You will see here the slight increase in that voltage, whereas in that stator voltage control there is a huge increase and decrease. Here it is a slight increase as well as slight decrease, as well as V2 also same, V3 also same. The load will differ over here, but the voltage is greater than the other voltages. See here, V1 is greater than V2 and V2 is greater than the V3. This is the variable terminal voltage control. Then the frequency control method. See, the frequency control method, we will have a maximum torque over on it. The main formula for that frequency control method is Vs divided by omega E, which is equal to constant. Then this torque versus frequency, we will have a graph over like that. See, all torque should be in maximum level, that is the Vs divided by W, that is constant. We will say this as a rated curve. By the changing the frequency, we can control the speed of above and below rated speed. See, if you are changing the frequency F, then we can control the above rated speed also and below rated speed also. Above rated, below rated. First of all, what is the meaning of rated speed? Rated speed is nothing but, as I said before, there is a formula to calculate the speed. N is equal to 120 F by P. Here we are using that 60 frequency. So we will give 120 into 60 divided by poles for the particular motor. Will have a turns over here is a 4 like that. Then we will have a RPM, speed is 1500 RPM. So this 1500 RPM is the rated speed for most of the motors. This 1500 is the rated speed of that most of the motors. So if we want to change the frequency, we will change the and control the frequency speed above and below the rated speed. It offered high range of speed control also. This is the curve for that torque versus stator frequency. We will have a maximum torque over on it also. Then stator current control method. See here, starting torque of induction motor T is proportional to square of a stator current. It is independent of supply of a frequency and it is independent of rotor resistance. The formula for the stator current method, Tm PR equal to 3 into XM ISDC divided by omega synchronous the whole squared into RR omega M divided by RR squared plus omega M X minimum divided by omega synchronous the whole square. This is the stator current control method. Then a constant current of three-phase induction motor can be obtained three-phase supply. The induction converter the DC voltage as a constant current source. Then CSI regulated the output and hence the torque of induction motor. Thank you.